stability. The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me, please. This whole world's confusing me. Clouds as mean as you've ever seen. Ain't a bird who knows you're true. Then a little voice inside you whispers, don't sell your dreams so soon. Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home. Everywhere you look, and everywhere you look.
Okay, ladies and gents, we're
Boys
so
and girls.
I'm pumped up. Same shirt, same teacher, same friend.
Different day.
New lesson. All right, let's do this. Lesson 1-5. We have our learning intention. We are going to be able to use visual models to divide fractions by fractions.
All right, success criteria. How do you know you're going to be successful at the end of your day? The worst part of coming to class and leaving is when you come in, you learn something, and by the end, you're like, what did I even learn? But guess what? We have it for you. 2 things. You will be able to use models to divide fractions by fractions. If you feel successful doing this, that means you mastered it. Secondly, you can use an algorithm to divide fractions by fractions. And what we learned last topic is when you divide a fraction by a fraction, you're going to use keep, change, flip. Keep the first value the same. Change that division sign to multiplication and flip that last bad boy and find its reciprocal and then multiply straight across.
Can you feel how excited we are right now? We're so excited.
We're amped.
Because we love when we find out that we prepare you guys for the future. This is
The future, Miss Conrado. I can't even wait.
Oh, you can. You don't even have to, actually, because it's here. We're about to do it.
Let's get after it. Tell me, what is my essential question for the day, Miss Conrado?
Since you're asking so nicely, Miss Flemington, it is, how do you divide a fraction by another fraction?
So kind. Thank you so much.
You're welcome. Okay, academic vocabulary is a word that I've seen. I know you've seen it too, because it's called reciprocal, and it's a pair of numbers that when multiplied together equal 1. Could have said that with my eyes closed, but keep going. When you change the whole number 2 into a fraction, like they show us in this example, by putting it over 1, the reciprocal, think about that flip, right, is 1/2. Because when you multiply them like we did before, we get 1.
Wow.
I know. Sorry, mic drop there. Mic drop moment.
We know. Example 1. Let's do
you know reciprocal. Let's keep going. Example number 1. Bar diagram. Here we go. We've worked with models, so let's use what we know in our example to help us solve. How much of a 3/4 cup serving is in a 2/3 cup of yogurt? I see this and I think easy, right? Find 2/3 divided by 3/4 and show 2/3 and 3/4. All right. So we are going to, just like Miss Flemington did, we're drawing the whole thing, and the third one is kind of lightly shaded, but it is shaded blue. And we are going to represent that whole cup, right, in parts of 3, and she only shaded 2. Then we're going to represent 3/4 in another bar, split it up into 4s because that's our total. And our part that they want us to look at is just 3, so that's why she shaded 3. So those two models is what's going to be represented here for 2/3 and 3/4. Now we're going to step 2. We're going to multiply the denominators to find the common unit of 12ths to compare, right? 2/3 and 3/4. So we're going to multiply the denominators to see how much we have to split these into. So 3 times 4 is 12. So we know that we're going to have to now split them both into until we get a single group, single units that equal 12 total. Okay. So when we split our first bar into 12, so just like Miss Flemington is doing, she's splitting both of them up at the same time just to save her some time. Into 12, right? Now, how many of that dark shaded blue area for our first one is, how many is shaded dark blue in that first bar, right? There's 8 shaded dark blue. Now let's look at the second bar, right? For our 3/4, how many shaded red now that we split everything up into 12? There's 9 bars that are shaded red. So now we have 9/12. So when 2/3 is divided into 8 equal parts, and 3/4 is divided into 9 equal parts, right? So 2/3 is 8/9 of a 3/4 cup serving. So what this means is we have 8 on our top bar and 9 on the bottom. Think if we just put a line to go right down the middle in between that, that's our answer, that's our fraction. Let's check our algorithm to see that, okay? So we have 2/3 divided by 3/4. Now let's think about keep, change, flip. We're gonna keep our first fraction of 2/3. We're gonna change our operation of division to multiplication. And we're gonna flip 3/4 into its reciprocal of 4/3. And now we can just multiply straight across. 2 times 4 is 8 and 3 times 3 is 9. Look at that, we got the same thing and we know we did it right. So excited.
Yeah, we got that.
So excited. All right, now we can go into example number 2. Andrew has 3/4 gallon of orange juice. He wants to pour it into 1/6 gallon containers. How many containers can Andrew fill? We need to find 3/4 divided by 1/6 to divide by a fraction. Then we're going to rewrite the problem as a multiplication problem using the reciprocal. This basically just told us that all we need to do is keep, change, and flip, right? We're gonna take the same fraction. We're gonna rewrite and change our operation to multiplication. And then we're gonna use the reciprocal to help us now multiply straight across. 1/6 gets changed into 6/1. We multiply straight across. 3 times 6 is 18. 4 times 1 is 4. 18/4. Let's simplify how many groups, because right now we have an improper fraction. How many groups of 4 can go into 18? Well, we know that 4 4s can fit to get a 16 with 2 left over. So we can write this 2 ways. 4 with a remainder of 2, or as a mixed number as 4/2/4, but let's simplify that fraction piece of it into 4 1/2. All of these answers that Miss Flemington is boxing are definitely acceptable.
Excellent. And then we have to check our answer this time going backwards with a bar diagram, right? So we can work backwards here. Okay, so we have 3/4 divided by 1/6. So first, let's start with our 3/4. We have a whole, and let's break it up into fourths. And how many should we shade? Good question, right? 3/4.
So 3 of those bars we should be shading.
2, 3. And then how much should we divide that value into? Oh, what's our second value? 6. So 1, 2, 3, 4, 5, 6, and we have one of those 6 1/6. All right. Okay, so let's move on to our try.
So in quadrant 2, we look at number 5. We see that they broke the number line up into fifths, right? And they broke it up into 4 fifths. 4 of those fifths. Yep, they pieced it into. And they grouped every one, right? So we see that they grouped an entire one of those pieces of those fifths. So it's going to be 4 fifths divided by 1/5. And how many of those did they group? We know that it's going to equal 4. So how many 1/5s are in 4 fifths? 4. So our sentence is going to be 4 fifths divided by 1/5. And that's going to equal, because we're trying to figure out how many 1/5s are in 4 fifths. And that's 4 pieces of 1/5 in 4 fifths. Super confusing. Don't stress. It's okay.
Oh, and then we're
Okay.
going to go head to quadrant 1. So find 1/4 divided by 3/8. And it says draw an area model and use the algorithm. Honestly, guys, you can go either way. You can draw the area model first or create the algorithm and solve. Let's just start with the algorithm just for sake of just kind of trying something different. 1/4 divided by 3/8. Our rule of thumb, right, when we divide fractions of any sort, right, we're always going to use our algorithm keep, change, and flip. Keep the first one, 1/4. Divide or change our operation from division to multiplication. And flip it, find the reciprocal of 3/8 is 8/3. Then multiply straight across. So 1 times 8 is 8. 4 times 3 is 12. I see that 8 and 12 are both divisible, right, by 4. So I'm going to divide out our greatest. So it'll be 2/3 is our final answer.
All right, guys, so really quick, how to represent this in an area model, right? If we use our bars that we did similar to example number 1, you want to find a common unit, right? With our denominators of 4 and 8 in both of our fractions, and our common denominator is going to be 8. So when we draw our first bar, we're going to break that up into fourths, and then we're going to shade just one part of the fourths. And then after that, because our common denominator is, or our common unit between our denominators is 8, you'll then split that bar into now eighths, okay? So how many do you still have shaded after you've done all that splitting? You have 2, okay? That's still shaded on that top bar. Let's move to the second bar. We have to split it up into eighths initially, right, first, and then we're going to shade 3 of those pieces, right? And because our common denominator unit was 8, we don't have to split it anymore because it was already split into eighths, right? So we'll just leave it as it is, and we still have 3 pieces shaded. So now we can see that we get the area of 2/3, which was, according to our algorithm, our final answer there. So they match and we are all correct.